Okay, so this is your review for your test that's tomorrow. Your test is going to look a whole lot like this. So if you can handle this review, you should have no problem with tomorrow's test. I think I've kind of looked ahead at that test tomorrow, and if I remember right, it's a non-calculator test because so many of them are so simple, and obviously I wouldn't want you to just type that into your graphing calculator and see what the graph looks like in Sketch. Like, that seems silly. So, but if there is something where you would need a calculator, I would give you kind of a heads up ahead of time. So let's rewrite this problem on the first little page here. So problem number 1 is x cubed plus 6x squared plus 9x minus 1. So domain, is there anything x cannot be? Nah, we're good. So we have negative infinity to positive infinity. And if it's negative infinity to positive infinity, do we have any vertical asymptotes? No, we don't. So I can go ahead and cross through those guys. And for this one, are we going to have any horizontal asymptotes? No, it's not a crazy fraction or anything weird like that, so it's just normal stuff. And we're also not going to have a slant asymptote. Some of you guys had asked me about this last week, and I think we mentioned it, but only like once, maybe, or twice. P of x is referring to the top function. Q of x is referring to the bottom function. And in this case, we don't have a top function and a bottom function. If we did, the top function would have a degree of 3, and the bottom would have a degree of 4, or of 0, meaning that the bottom was just a 1. So that's kind of where that comes into play. The reason we cross these out, number 1, is because we don't have to mess with them, and number 2, you need Mrs. Major to know, I see that question, I did think about it, and I don't have to do it. If you leave it blank, I'm just going to think you don't know. Does everybody understand the difference? When I graded your packets over the weekend, if you left it blank but you didn't cross it out, I did count it wrong. Because I think I've said that every time I've crossed it out. I've said, so I know you've thought about it. So make sure you cross those things out. The range will pick back up at the end. It wants to know where the x-intercept is. That's where you take the y and replace y with 0. Now, where's our problem here? Do we have an issue? Kiana? Because we don't have any kind of a rational function. Yeah, it's just a straight up regular old polynomial. There's nothing weird with it. Are you going to be able to solve for x on this one? Yeah. No, so this is one where you would either get to use your calculator or I would just tell you what the x-intercepts were. And in this case, the x-intercept is at 0.10, comma 0. And I'm trying to remember if there's another one. Nope, that's it. There's just the one. Okay? Now, here's the thing, and let me write this in a different color. I could tell even after making a really big deal about this last week, some of you guys were still confused whenever I graded your packets. If you have something like this, I still have several of you that are trying to add 4 to both sides so that you can factor. That is not going to work. The reason we do the whole factoring thing when you have a quadratic, meaning the degree is like a 2 or a 4 or a 6, something that's even, is because if you've got 0 set equal to a couple of binomials, you have something times something equals 0. The only way to get 0 when you multiply is that one or both of those equals 0 to begin with. That's not going to happen when you're trying to get something to equal 4. There's an infinite number of possibilities to get 4 when you multiply. It could be a fraction times of another crazy number. It doesn't have to be 2 times 2 or whatever. Does that make sense? It has to be a 0. If you don't have a 0 over there, forget it. You can't do it that way. Are there any questions? Okay. The y-intercept is where we take x and we replace x with 0. When I do that, I get a negative 1. So if I put in 0, I get negative 1. The derivative of f of x, we just do the power rule. This one's a pretty easy one. We get 3x squared plus 12x plus 9. And now we're going to set it equal to 0. What's your first step? What do y'all want to do? Yeah, you can divide by 3 or take out a 3. Either way, you're going to get the same answer. So we have x squared plus 4x plus 3. It is factorable. X's are in the front. In the back, we have a 3 and a 1. And what are my signs? Good, they're both positives. Which means x could be what? -3 or -1. It wants to know where the derivative is undefined. Is there anything that will make it undefined? Nope. So we say none. It wants to know where it's increasing and decreasing. That's talking about the first derivative number line. When I do the number line, what numbers go on here? -3, -1, because those are our critical numbers here, and that's it. Ocean, what do I do once I get this far? Okay. Thank you. -4 into the derivative, he says. Figure out if it's positive or negative. Very good. Thank you. So we have -4, and if I plug in -4 here, am I going to wind up with a positive or negative when we're all done here? A positive. Good. If I put in -2 into this thing, am I going to wind up with a positive or a negative in the end? A negative. If I put in a 0, I'm going to wind up with a positive. So we are increasing from -infinity to -3 and from -1 to infinity. We are decreasing from -3 to -1. Questions so far? Is everybody okay? Okay, so we have increasing, decreasing, increasing. What does that tell me about -3 and -1? Yeah, our maximum and our minimum. We have a local maximum at -3 something and a local minimum at -1 something. How do we get the y value? Plug it into the original. The whole reason we're doing the derivatives is to figure out some clues about the original graph. We know that there's a maximum at -3. Well, on the original graph, I want to know where that is. So I say -3 into the original graph, or original function, I'm sorry, and I wind up with a -1. If you take a -1 and you plug it into the original function, you wind up with a -5. That's what first hour said. I assume they're right. Somebody borrowed my calculator, so I don't even know. Did she give it back, in fact? Yes, she did. Okay. Second derivative. We look at our first derivative and we perform the power rule. So I wind up with 6x plus 12. It wants to know where it's equal to 0. Good. So it happens at -2. It wants to know where it's undefined. None. Good. And it wants to know concave up and concave down. Whoops, I don't know what just happened. That should say second derivative. What numbers go on my number line? -2. Anything else? Nope, just the -2. So you're only concerned with where it's 0 and where it's undefined. Those are the only things that need to go on the number line. So if I take a -3 and I plug it in here, I wind up with a negative. If I take like a 0 and plug it in here, I wind up with a positive. So we are concave up from -2 to infinity. We are concave down from -infinity to -2. Inflection point, do we have one? Yes, where is it? -2. When would I see a change in concavity, but yet that not be an inflection point? Yeah, if there's an asymptote there, if it's undefined, and it's not, so we're good. So -2 comma something, when you take the -2 and you plug it into the original, you get -3. We've already kind of X'd everything else out, so now we can start drawing. I don't have any asymptotes to put on here to kind of give me a framework, so we're just going to start putting in points that we know we have. Also, you're going to have to figure out your units, especially on your test tomorrow. I don't want to wonder how big each unit is. Because I've done this one before with first hour, I'm going to call the very top is 4, the bottom is -4, the far right is 6, and the left side is -6. So that each one of these little divots is 2, those little tick marks. Yes, sir?
How do you advise, because like we didn't know kind of what the scope would be?
You could still graph it, it would just look like this.
Oh.
It'd just go off the page. And actually that's not inaccurate, it'd be longer than that, but I tried to squeeze it on. Yeah. So you could start it and you could erase, or you could just redraw another sketch or whatever you need to do. Let's look at our points. I've got 0.1, 0, sorry, is one of my x-intercepts. So that's like just snuggled up right next to that little guy. I also have one at 0, -1. So 0, -1 is going to put me about right there. What else do we know? Yeah, we have a maximum and a minimum. There's a local maximum at -3, -1. Whoops. And there's a local minimum at -1, -5. So it does kind of go off your graph just a little bit. Do we have any other points? Yes. What is it? The inflection point is -2, -3. It's going to be harder to see on this one, I can tell. Those are all the points that were given. So now we have to look at concavity and is it increasing or decreasing. So right here, x is 3. So I need to know what's happening left of 3. If I look at my number lines, left of -3, left of -3, it's increasing and it's concave down. So I'm thinking it must do this. And I also know that that's a local maximum. So I know that it kind of tops out right there, meaning it probably heads back down. And if you look at increasing, decreasing, yep, according to your number line, it's decreasing and it's still concave down until it gets to this point, which somebody told me was my inflection point. So we were concave down, so we were frowny face, now we're starting smiley face. I know that this little guy here was a local minimum, so it kind of bottoms out right there, and it probably heads back up toward the top. If you want to double check up here, you can see, oh yeah, I'm increasing now, and I'm also concave up, so I'm part of a smiley face. I'm still doing that here, and I'm still doing that here. Does everybody kind of see my reasoning and how we did all that? So what I'm looking for in your test is, yes, I'm looking for concave up, concave down, are those things correct? But I'm also looking for 1, 2, 3, 4, 5 points to be on your graph, because you were given those 5 points over here. Does everybody understand? And as far as how steep this little guy is, I'm not really concerned with that as long as you know that it's concave down and it's headed downward. Or technically it's increasing, I guess, for that matter. Okay? Range, thank you, because I forget every time. I won't forget to grade it though. For the range, what is our range? Yeah, it goes down for forever and up for forever, so this one's pretty easy. Everybody all right? Is there anybody in here who has questions about anything on this page? If you saw this tomorrow, this exact problem on your test, could you do this? Yes, sir. Yes, you may see the sketch. Everybody's all right then? Terrific. Next one. Problem number 2. Go ahead and write it in if you haven't already. It is x over 1 minus x. Or, and we might need this later, I'm going to rewrite it as x over negative x plus 1. That might help us later too. It means the same thing. Domain, our x values. What can x not be? Can't be a 1. So I can go all the way from negative infinity to 1, skip 1, and then pick it back up and go to infinity. X-intercepts are where the graph equals, or where the equation equals 0. I set this equal to 0. I really only care where the top is equal to 0, which means I have an x-intercept where? 0, 0. So when y is 0, x is 0. I have a y-intercept where x is 0. So 0 over 1 minus 0 is 0. So if I plug in a 0, I get a 0. First derivative. Yes, you are going to have to do some quotient rule. I'm going to use the first version over here. So I have the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Any questions with how I did that? Okay, let's clean it up. So on the top I have 1 minus x and then minus a negative x. Does everybody see what just happened? Over 1 minus x, the quantity squared. So I really have 1 over 1 minus x, the quantity squared. When you're writing it in your little blank, just make sure that if you use that little slash mark for your fractions, that the entire numerator winds up in a parenthesis, within parentheses, so that I know that the whole thing is the numerator, not just the last number. Bless you. If we set the derivative equal to 0, well, it's a fraction. If we set the top equal to 0, when is it 0? Never. 0 is never going to equal 1. So for no x's. Where's this thing undefined? If x was 1. It wants to know increasing and decreasing, so it's asking us to make our number line. What numbers go on the number line? Just 1. And I'm going to draw myself an asymptote there, because I know that's where it's undefined, so it's not connected there. If I take a negative, or if I take a 0 and plug it into the derivative, what do I wind up with? A positive. And if I take like a 2 and plug it into the derivative, what do I wind up with? A positive. And you knew that was going to be the case because the bottom is squared. So the bottom is definitely going to be positive no matter what. Alrighty, increasing and decreasing. So we're increasing. Can I say from negative infinity to positive infinity? Why not? The whole thing's increasing. There's an asymptote here, so we skip 1. So we say from negative infinity to 1, and from 1 to infinity. And it's never decreasing. What about our local maximum and minimum? None. We don't have any. Second derivative. Okay, so I'm going to start with this little guy over here. So we have the bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom. What is the derivative of the bottom? 2 times 1 minus x. We leave the inside alone. Good. So here's where she got it. I'll explain this one last time. This 2 pops over to the front. Leave the inside alone. It was squared. Now it's to the first. Derivative of the inside is a negative 1. Over bottom squared. So we have 1 minus x to the 4th power. So we simplify this. I have a 0 in the front, so all that goes away. I have a negative 1 times a negative 1, so that makes that a positive, times 2, and I'm going to multiply 2. Well, no, I'm not. I'm going to leave the 2 out for a minute. You'll see why in a second. What would you do with that? Yeah, we can take a 1 minus x out of everything. Oops, that's a 3 now. Sorry, my bad. I said that and then I didn't do it. So there's our second derivative. It's 2 over 1 minus x, the quantity cubed. It wants to know where the second derivative is going to equal 0. Is 2 ever going to equal 0? Nope. Yes, sir? If you distribute it, then I'd probably just take off like 1 point for not completing it. Yeah. Let's see here. Second derivative. Where is it undefined? If x is 1. Concave up, concave down. That's where we do our second derivative number line. What numbers go on this thing? Just 1. And I'm going to draw an asymptote so I don't forget that that's actually where it's undefined. If I put in a 0 into the second derivative, I wind up with a positive or a negative? Positive. If I put a 2 in for this x right here, do I wind up with a positive or negative? Negative. So we are concave up from negative infinity to 1. We are concave down from 1 to infinity. And what's our inflection point? Tricky. Very good. We don't have one. The concavity did change, but it's at a place where it's undefined, so there isn't a point there. Vertical asymptotes. Do we have any? Yep. At 1. We don't have another one, though. Whoopsies. So as we're approaching 1 from the left, what number am I going to put in? 0.9999. When I do that, and I have 0.9999, so it's a number, it's about 1, divided by 1 minus 0.9999. Isn't that a teeny, teeny, tiny positive number? So regular number divided by teeny, tiny number is gigantic number, and it's positive. Approaching 1 to the right, what number are you going to put in? Yep, 1.001. So I have basically 1 divided by 1 minus 1.001 is a negative teeny tiny number. So what's the answer? Negative infinity, good. Horizontal asymptotes are tricky for some of you guys. You can either plug in like gigantic numbers, imagine that there's infinity there, or you could do this either way. If we look at the rewrite, it's a little bit easier. Remember I said Bill Gates doesn't really care about this extra dollar? He's probably not concerned by that. What happens when you reduce that? What do you get? Negative 1. So it's approaching negative 1 no matter which way you slice it there.
So how do you tell there's the horizontal asymptote?
You can either memorize your rules, or if the degrees are the same, Carson, you just do leading coefficient over leading coefficient. So 1 divided by negative 1 is negative 1. Or you could kind of reason it through the way I just did. You can kind of throw away your extra dollar there, kind of reduce what you have and see what you get. Also, you would know, Carson, down here, this is talking about the degree of the top of the top function, which in this case is 1. The degree of the bottom is 1. If this was 1 larger than the bottom, that tells you there's a slant asymptote. Which in this case, because we have a horizontal, we know there's not a slant one. Does that make sense, Carson? Okay. All right, sketching the graph. I'm going to start with my asymptote because that's going to give me kind of a framework. Our horizontal asymptote is at negative 1. No?
Is Christian here?
Christian. Yep.
Christian Duncan?
Yep. He's here.
Good access here.
Thank you. So we go to negative 1, and we put in our horizontal asymptote. I'm going to make this negative 2, positive 2, 3, negative 3. I have a vertical asymptote at 1, and this kind of gives me a kind of a skeleton to start with. I've got several points I can put on here, don't I? Really, I think I just have 1 point now I say that. We have 0, 0. Do we know any other points? We don't. That's it. So we're really going to have to focus on concave up, concave down, increasing, decreasing, that whole thing. To the left of 0, let's look at our number lines and see what happens. To the left of 0, it is increasing, and it's concave up. So smiley face, and it's increasing. And the other thing to remember is, because what I want to do is I want to do something like kind of crazy here, but if you think about it, as this thing is approaching negative infinity, it's approaching negative 1. So we're increasing, it's concave up, and now it's approaching negative 1. Between 0 and 1, increasing, concave up, so it finishes out the smiley, and I know that it is approaching positive infinity according to our limits here on the left. You guys can probably guess what the rest looks like. But if you, if we read this, it is concave, or it's increasing on the right-hand side, and it's concave down. So we're constantly increasing, and it's concave down. We're still approaching negative 1. This guy, as we head toward 1 from the right, it's approaching, excuse me, negative infinity. Questions on this guy? Okay, last one. Piecewise function, which I think up until this lesson probably freaked most of you out, but on this lesson, it's kind of the good stuff because it's usually a little bit easier. So we have radical x where x is greater than 1, and we have x squared minus 3x where x is less than exactly 1. It wants to know the domain. Now before I even get started, I do want to check something here. It looks like x can be anything that's larger than 1 or anything smaller than 1 and exactly 1. If I look at this, x, it could be 0, but it can't be a negative number, right? But we're covered because in the restrictions it says it has to be bigger than 1. So on the top we don't have anybody that's undefined. On the bottom you're not going to have anything that's undefined anyway. So we're fine. Our domain does cover negative infinity to positive infinity. But something that is smart to check from the very beginning, these piecewise functions, sometimes, you know, it does something crazy, it stops, and it picks up where it left off sometimes. Sometimes you get something funky like that, and there's jump discontinuity. All your x's are funky on. It's kind of good to see if that happens on this. So if you take a 1, if you were allowed to put a 1 in, you're not, but let's say you are, what would you get? 1. So this thing is going to have an open dot at 1, 1. If I take a 1, which I'm allowed to this time, and I plug it into the bottom, I'm going to get 1 minus 3, which is, if I put in a 1, I'm going to get a negative 2. These two have jump discontinuity. They don't pick up where they left off. You're going to have something like this. So just kind of keep that in the back of your mind as we go through this. Range, oh, did we do range? Nope, we didn't. Back up. What's our range on this guy? Negative infinity to negative 1, and then it skips. Good. So negative infinity to negative 1, it picks back up at negative 1 to infinity. Good. Sorry about that. Yeah, I would take that. Just know that I think it is more common for people to use interval notation, but I would take that. X-intercepts is where y equals 0. Well, y is going to equal 0 at the top if x equals, is x allowed to equal 0? Nope, so we're good on the top. We don't put anything. Where's the bottom one going to be equal to 0? If x is, I just realized I messed up first hours. You're not sure? Let's check this out. I factor 0 and 3, right? Yeah, I think first. Is x allowed to be 0? Yes. Is it allowed to be 3? No. So we just have one place. So we would say at 0, 0 is the only one we're left. Because if y is 0, x could be 0. Does everybody understand why I did not use here? It does produce 0. The problem is that x has to be smaller than 1. That's why. Everybody okay? Okay. We take x and we plug it. We make it a 0 and we plug it in. Plug it in the top, bottom, or both. Bottom, because that's where it's allowed to be 0. So we plug in a 0. Top is going to be x is greater than 1. Bottom is x is less than or equal to 1. I'm going to start with the bottom one because it's for the top. X is x. For the derivative, we have 1 to the negative. You could rewrite that as 1 over 2 radical x, or 1 over x to the 1/2. I would take it. So I'm going to say 1 over 2 radical x. If I said this equal, is anything going to make that 0? If the top number is a 1, three halves is 1.5. Is that less than 1? Nope. So we'd say alrighty. Not really, because even though there are make So we say none. What goes on the number line? How come 1? Where'd that come from? Something could happen at 1. It might not, but something might. So where it's x is less than the left go on the top one, where x is greater than 1. Do I get a positive? I wouldn't call it that because you do have a point that exists like right here and right here and right here. -2, we already figured that one out. Is everybody okay on max and min? Okay, this little guy, him right there. Right there. Yeah, go to sit there. And then this guy.